Right, so I'm going to outline how a teacher can use Jupyter Hub to be able to integrate Python-based worksheets. So what I'll do here is I'll log in with the admin account into the Jupyter Hub. Okay, and then over here, I'll log in as a student would there. Okay, so from the control panel here, the server is running just now, but we can obviously stop the server. And I've set up 3 users, net 0, 1, 2, and 3. So we can go ahead and start the server here. Okay, so whenever net 0, 1 logs in, they should be faced with some of the labs that we're going to set up. Okay, so we'll go with net 0, 1. And here are the labs here. And the lab that we're going to be looking at is this one here. Okay, so the student would see this there, and that is their own server environment to be able to run the workbooks. Okay, but for us, what we'll do is we'll just have a little look around. Okay, so here's the files here running on the system. Anytime we can actually open up a terminal to be able to have a look at our setup. So I've got one running here. Okay, and this should show us the setup that we have on the server. So if I go in here, then we should be able to see here are the Iron Python workbooks that we're going to set up. Okay, so I've also created a folder called graphics that I've put into my I put my PNGs in. Okay, so here we are. So the one I'm going to show you is to learn hashing methods and cryptography. So here's the workbook here. Okay, and if you've used these Jupyter notebooks before, you'll see that is running code here. And so whenever we come to the code, we can just execute it as we require, and we can edit it from here too. So as I'm the administrator here, setting up a class, I've created a notebook here, and then what I'll do is I'll copy that notebook onto the student logins. Okay, so the way it works is that we have what's called a Markdown language, and we either have code or we have Markdown language. So in this case, we can either show it as a Markdown language, and if you've used GitHub before with a markup language, these are the headings that we have, level 1, 2, and 3, and so on. And we can integrate HTML tags into there too. Okay, so in this case, I've just edited and I've just added some text here, and then we can just flip. Sorry, we can go back to a raw code or back into Markdown. So what you find when we're into Markdown, we need to run this code. So we say run, and then that will render the code as required. Okay, so I'll just show you that again. That's our raw code. You can see here we've got our text and our headings and so on. We flip back to Markdown, we can still see the markup Markdown there, and then we've got to run that to be able to show it rendered. Okay, so I've put the graphics into a folder and then I run them off the server. Okay, so whenever we want to add a new element, we'll default into coding in there. So I can just say a string 1 equals hello, and then print string. So I normally use this format for rendering the values into the string, where you put brackets around the variable name. Okay, so once you're in there, you then should be able to run the code, and obviously we've not run that correctly. It's the wrong name of the variable, so you can run it and get the result here. Okay, so that's for code, and if we want to delete that, double D gets rid of that too. But we can add a text block that we want. When if we go to here, call markup, this is a test, and we can do our markdown language here, and we can obviously just run that, and that gives us that. Okay, select it again, and we'll just delete it. So I've integrated some code into here, and so this is using the HMAC primitives that are in cryptography. So I've tried to keep the same library in here just to show how it actually works. Okay, so we've got a string here, we encode, and that allows us to be able to convert our values into bytes. So we'll take a ASCII character array and then encode them into bytes. We can then feed that into the MD5 method with the MD5 method and create our hash. In this case, we're using bin ASCII library to convert into hex values and as a string, and also into base 64. Okay, so this should give us the two values for hexadecimal and for base 64 for our input. So if we try hello 123, again we go here and then we can make sure that we get the right output there. Okay, so you can see I've got some markup here, it's still in the raw form. I'll put it back in and I'll render it to there. So here are the questions that the students are asked. In this case, what's the output for hello? We can go back in here and then we can see the answer to that is 8B. Now we'll modify line 11 of the following program to give us SHA-1 or SHA-256. So we can add line numbers. As you can see, there's line numbers in here, and we're going to modify this one so it gives us the SHA-1 output. And again, we'll just run that one, see what we get. Okay, so that's how you create your workbooks, and I've integrated the code in here, and every so often I've got questions in there that can be asked, and then the code. And you can see how easy it is to integrate the code and then for someone to go and modify it. Okay, so if you're interested the actual code itself, this one here. So if you want to see the core format, so we can easily copy and paste this into Visual Studio and Visual Studio Code, and we can edit from there. But this is what the file actually looks like when we run our workbooks. Okay, so you can easily go in and modify this one, and then you can paste it back in, and that will give us our basic setup for the workbook. Okay, so what I normally do is I'll copy the files I've created from the folder. I just need to move up. I just copy those files and the folders into the user spaces. So now we'll try to see what happens when the user logs in. Okay, so this is what they should get. I'll just update that one, and then we're going to be running the hashing one. Okay, so this is the user. The user will see that this is a read-only, so they can't actually save the file, but they can make a copy of it. So for us, the great advantage here is that we can save, and we can also set up a checkpoint. So the checkpoint allows us to be able to return to previous versions in the past. Okay, we can also download the file so that we can edit on our own machine. Okay, so this is the user. The user will go in and hopefully read the details from that one. Okay, so just let me check. Okay, so here we have our workbook, and again it's just the same, but the students can run the workbook as required, and then they can try different hashing methods out. This is particularly convenient when we're demonstrating the method. We can easily go in and modify things. In this case, we'll update with SHA-256, and hopefully we'll be able to get an output from there. You can see there is the SHA-256 format there. Okay, then what I've done is I've integrated a range of the methods within the HMAC primitives to be able to give all the hashing methods that are possible. We can easily go in and change our value here, and then that will give us each of the hashing methods outputs for that one. Okay, so all I'm doing is to pass in the method here into the type field, our data, and then the name of the hash, and we're just doing this within inside a little method called showHash. Okay, the second principle that we're displaying here is the usage of HMAC. So with HMAC, what happens is that Bob has a secret key and or a secret value, secret key, and also Alice has the same secret key. Then what happens is that Bob will sign the message for a certain hash value with the secret key to create the HMAC. Then Alice will do the same when she receives that HMAC value and compute our own HMAC value with the secret key that she had between Bob and Alice. She compares these and she knows that Bob has signed the HMAC or the message with his secret key. Okay, so here's the implementation here. We're using the HMAC function now with a key, and we'll use a certain hashing type, which is MD5 in this case, and then we'll just print it out in hex and base64. Okay, so we can run this one here. We're just using key. We're converting key into bytes. We're converting our message into bytes, into byte array, and computing our HMAC. So if we run here again, so we now see that for this message and for this key, we get this HMAC. We get this HMAC value, and here is the equivalent in base64. Okay, so we can go ahead and we can modify the methods from here. If we're going to use SHA-1, which is 160-bit hashing method, we'll just run that one. And here is our output method. We obviously have to change that one there to give us our output. Okay, so here is the HMAC for SHA-1 for the data input of this, and then for the key as that. In this case, we're not adding any salt values to it. Okay, and then we can go and implement this again with the methods, pretty short HMAC, and these are the methods here. So again, we can just modify this quite easily, and we can run that and see what HMAC values that we get with this key. Then we can modify it so that we have a different key. So we have a key of QWERTY. Let's see what happens when we run the code. There is our output values. Okay, so we just need to run this part here, and we can implement this part. Okay, so the third principle covered here is the usage of HMAC Keydelevation functions. Okay, so in this case, what we do is that we take a password on either side, we generate a key derivation function or an encryption key, which will then be used to encrypt and also decrypt. So in this case, we don't generate a random key, we generate a key that both Bob and Alice know and can generate the same key using HKeyDF with a certain hash method. Okay, so this is simple version here. So we're using this method here, using a certain hashing method, and this time we're adding in some salt. It just happens to be empty here, and we get a certain length. So in this case, 16 bytes is 128 bits. So we'll just document that one. We have to come back to it. Encryption key. But if we want a 256-bit, we will put in 32 there. So just go over 16. This is the password that we're going to use. We convert it into bytes for both that and the salt, and then we'll generate this one. And we'll see how that goes. There we go. So here is the key encryption key that we're generating for SHA-256 with a key of test. So we can easily go back and modify that one, and then we can add in some salt in there, and that will generate a new encryption key. We can also go back in and modify it, so we're using a 32-byte or a 256-bit encryption key. Again, and we should see the key derivation function output double in size because we're varying the length of the key. Okay, so we can very easily change the method that we have here, and this time we'll go for SHA-1, and it won't change the length of the output, it just changes the method that's used to be able to generate the key. Okay, and then we can advance on to look at the other methods such as script and PBKDFS2, and we'll just make a little note here because that needs to be changed for that one. So let's try and find where we are. Okay, because it's called PBKDFS2. Okay, we'll go back to markup again, and then we'll run that. Everything's there. So these are the slow methods, and then these will defeat the GPU crackers. So in this case, we're integrating script and PBKDFS2 and a couple of other methods in there, This time we'll just implement these with the method, and there's a few other options that we can apply into script to change the parameters. With PBKDFS2 we have a number of iterations that we go through. Okay, so again we'll go through each of the core methods for HMAC, but then we'll also show for PBKDFS2 and for script. Concat is another method that we can use to its equivalent from there. Okay, so we'll just run that, see what we get. Okay, we can see here we've got test and the ones we're looking for, the PBK DFS2 and also for script. As I said, these are much slower and they defeat the GPUs. Okay, so you can see what a powerful method using this Jupyter notebooks is. We can easily integrate all of our content and our Python code, and to be able to create workbooks which create a safe environment for students.